So in this video, you will be the one doing the work. You will design the cache. So we're going to build a cache of size 64 kilobytes. The cache line size is 64 bytes and the word size is 8 bytes. It's 32-bit addressable, byte addressable address as an input to this cache. So this would be a typical first level cache in an x86-ish kind of architecture that you would see in the typical products today. So here we have the address, it's 32 bits, and here is the data array. So we said that the cache line, the word size is 8 bytes, and we say the cache line is 64 bytes. That means we're going to have 8 words, each 8 bytes wide, so 64 bits is what you see down here. And our goal is to provide a word to the core, to the processor. So we're going to provide 64 bits to the processor, and we should provide a hit signal. Okay, now is when the fun starts. So we're going to have some kind of select mux there as well, and since we have 8 inputs and 1 output, it's an 8 to 1 mux. So now you start your work. How many select bits will we need? Well, you need 3 because we select 1 out of 8. How many entries are there in this cache? Well, there is 1K entries because it's a 64 kilobyte cache, and each entry has 64 bytes because that's the size of a cache line. So 1K entries. How many index bits will we need? Well, 1K entries, that implies 10 index bits. How many bits are used to identify a byte within a word? In other words, how many of these bits can we toss over our shoulder? Well, the word size is 8 bytes, so 3 of the bits can be tossed over our shoulder. So I gave this one away without a question. So we need 3 bits. The next following 3 bits will be used as input to the select signal because we choose 1 out of 8. And then we're going to use 10 index bits. So that's the next index bits here will be used. How many address tags will we have? How many address tag bits will be stored here, and how many of them will, well, let's leave it for that. How many address bits are going to be stored here? It's going to be 16 bits because that's how many bits that we haven't used so far, either tossing our shoulders as a select or as an index function. So all those bits, of course, will be used. Will be compared with the address tag bits. So that's it. That's the design. And here I'm just showing a clean copy of the previous slide for the handouts.